So checking here what's the differences between assignment, copy, and deep copy. So in order to understand, let's create a very short program, import copy, and we create a original. And this is it has one element, and it also has another element, which is a list of list. And this is particularly required to demonstrate the deep copy. Okay, and now let's create three variables from this one. X is equal to original, so we are just use the assignment for the X, and for Y we will use the copy dot copy. So we have created the Y using the copy of the original, and Z we will create using the copy dot deep copy of the original. And let's do one thing also to print all of those values, that every time we can see what changes we have made. So we can say the original is equal to original. Similarly, we can say X is equal to X, and slash n. Y is equal to Y, and slash n. Z is equal to Z. Okay, so we can print and we can see that all are same. Okay, so now what we will do is we'll make some changes here. So we'll make some changes into the values of the X. We'll not touch Y, Z, and the original. So let's say I'm saying X0, the first element is multiplied by the 5. So I'm saying X0 is equal to 5 now. And similarly, I'm also saying that Y1, X1, not Y1, X1 is equal to it. It also becomes multiplied by 5, so which is 15 and 20. Okay, so now if we print this value, we have made changes into X, but we have not touched the original as well as Y and original Z. But let's see what happens here. So we can see it here that although we have made changes into X, but original also gets changed. So because there is a binding here, so they refer to the same, they have the shared memory now. Okay, so X and original refer to the same. There is a binding. We will see just now soon the documentation also. So the Y and Z has not been changed. Okay. Okay. So I'm copying again. And now what I'm going to do is, instead of saying X1 is equal to 1520, so I'm going to make these changes one by one. So right now, what we have done here is we have made changes to the entire object, and we have replaced it. Earlier it was 34, and now we have replaced by 1520. So now I'm saying that X10 is equal to 15, and remove it here, maybe just 15. And then I'm saying that X11 is equal to 20. So technically, these two statements are equivalent, whether you write like this one or like this one. So instead of using this statement, so we have now split it. Okay, so you can see now, so once we run this code, so now Y has also been changed, although we made some changes into X only. In this case, Y was not, there was no impact on the Y, but now Y has also changed. The reason behind this one is that Y is a shallow copy and Z has still no impact. So Z is a deep copy. What's the difference between a shallow copy and deep copy is, so shallow copy creates a shallow, means outer architecture it copies, but the objects are still by the reference only. So they still have the refer to the you can say the original one. Okay, so you can also do one more example here. So now if we are only making changes in the X, so now it doesn't matter. So you can make changes in the X, which is okay. You can make changes in this one, which is okay for copy, but the moment you create, you make changes here, this element, individually these elements, maybe one of these elements or both elements, if you make changes in this one, so these changes will be reflected in the copy also. So these changes are not something which are only in the copy, but deep copy is not impacted by any change. So because it creates a copies of all the nested objects. So simply you can assume that copy creates a shallow copy means only this part is copied. This one is copied, but this 3 4 is still by the reference. While if you consider the deep copy, everything is copied. So you can make a change into the copy without worrying about whether the original will get changed or not. Okay, so that was all about the assignment, copy, and deep copy. Thank you.